Hi everyone, today we will talk about the different type of control signal. So I have drawn the timing and control unit that you can see over here, and all the control pin, hardware pin, which release the control signal is connected over here. So we have also seen this part when we were demonstrating the architecture of 8085 microprocessor in the previous lecture, which is lecture 2. So now what we will do, we will talk over all the function of individual control pin. So let's demonstrate, let's discuss all the function which is related to the control pin. So let's first our here I have taken our first control pin, which is x1, x2 and clock out. This is our first control pin. These three are our first control pin. As you can see, x1, x2 and clock out. The pin number is also depicted here, 37, 1 and 2. So this x1, x2 connected with a quartz crystal oscillator. So this quartz crystal oscillator provide the oscillations to the timing and control unit. And what does it call? It's called quartz crystal oscillator. Quartz crystal oscillator, it produce some frequency and it pass that frequency to the Smith trigger that is connected over here, that you can see it is Smith trigger. Smith trigger circuit is over here. So when the frequency will be passed to the Smith trigger circuit, the Smith trigger circuit will produce the actual frequency, in which frequency the timing and control unit or the microprocessor is operated on. So for 8085 microprocessor, this frequency is basically 6.25 megahertz. 6.25 megahertz it will produce. Our Smith trigger will produce 6.25 megahertz. So now here let's comes to here. This is a quartz crystal oscillator which produces the frequency. So not only the 8085 microprocessor, but all the microprocessor which are available in our market, for all the microprocessor we use this quartz crystal oscillator as a frequency generator, So what is the advantage, what is the specialty of that device? So the specialty of that device, it gives us highest accuracy, as well as it also provide us frequency stability. So due to this two reason we use this quartz crystal oscillator for all of the microprocessor to generate the particular, to provide the frequency to the circuit. So that was the quartz crystal oscillator. Let's comes to here. So it produces the frequency, will supply that frequency to the Smith trigger, and Smith trigger will generate a particular frequency which is 6.25 for 8085 microprocessor. Now as you can see over here, this frequency is the input frequency to the JK flip-flop. So JK flip-flop, if I will draw a JK flip-flop here, JK, and if there will be input frequency, if output frequency will be what will be the F out frequency? So you might have read the topic in digital that if there will have n number of JK flip-flop, is connected over here, number 1, in that way it will be in J K, and if out and that will be f in. So if there will have n number of JK flip-flop is connected over here, and if we will provide f in the first flip-flop, then what will be the output we will get from the n number of flip-flop? From the n number flip-flop, that case we have seen f out will be f in by 2 to the power n. Do you know the formula? F out will be f in 2 to the power n. Here we have a n equals to 1. One JK flip-flop is here. So what will be the output frequency? Output frequency will be f in, which is 2.25 megahertz, and it will divide by 2 to the power 1. So it is 2. It's 2. So the output frequency will be 3.125 megahertz. So that is the output frequency, that is a clock frequency. So in this frequency, the 8085 microprocessor operated on, which is 3. Basically the ideal frequency is 3 megahertz, but never the analog circuit will provide the ideal frequency. That's why the 0.125 is an error frequency which has come. So this is a ideal frequency of 8085 microprocessor, which is 3 megahertz, and this we get 3.12 megahertz. So this frequency is operated in this frequency, the 8085 microprocessor is operated on. But I have one question here for you, that why when we will send a frequency, provide a frequency f into the JK flip-flop, and we will get a frequency f out, so why the output frequency for one flip-flop will divided by 2? Why the output frequency? That means why this thing happen? F out, f in by 2. Why this thing? Why does this thing happen to JK flip-flop? What is the answer? If you know the answer, then comment me below. So in our next pin, in our next control pin, so let me erase this whole thing first. So in our next control pin, which is a read bar, as you can see over here, this pin, read signal. So this hardware pin is active at low. Active at low. What does it mean? Means that when it will be activated, this pin will be activated when, or the signal will be activated when it gets low value. That means if it will get RD equals to 0, that means RD bar will be 1. That means active. If hardware pin get the 5 volt or the high value, then the RD pin will be low or will be deactive. So these were the basic features of read signal. So if we want to activate the read signal, you need to provide a low signals to this read pin. You need to provide the low signals to this pin. So what is the use of this pin? What is the use? So mainly, if microprocessor needs to, or the user, if microprocessor needs to read some operation from a particular memory location, or it could be a particular input port, so it enable the memory location or the particular input port, and allow the user or the microprocessor to read some data from the particular memory or from the particular place, and also store the data to the data bus. So let me repeat again. So if what is the use of read operation? So mainly if microprocessor wants to read some data from the microprocessor memory or the input output port, so it enable the particular memory location or the particular input output location and allow the microprocessor to read some data from that particular port or particular memory location and store that data to the data bus. That was the basic operation of read. So our next operation, our next pin, which is the write pin. So write pin, so this is also the active at low, active at low. That means if you will provide low value, if you will provide low value 0 volt, then this pin or this signal will be active. Then that means the write operation will active when you will provide the 0 volt, and if you will provide the 5 volt or write will be 1, so then means the write operation will be deactive. So this is the same like the previous one, read operation. So if what is the use of this write operation? If microprocessor wants to write some data into the memory location or into the output port, into the memory location or into the output port. So if microprocessor wants to write some data into the memory location or the output port, it means that this signal, this pin will enable the write, it will enable the memory location or the output port first, and will allow the microprocessor to write some data into that particular location or the particular output port. So that is a basic operation of read. So you wants to read something, microprocessor wants to write something, or microprocessor wants to read something. So before these two operation, microprocessor first need to activate these two signal, read signal or write signal. So these two signals are quite resembles to each other, like these two signals are active at low. Now our next pin is input output or memory, that is this input output and memory. So this is our fourth control signal or fourth control pin. So input output and memory. So this hardware pin helps to the microprocessor to get the difference between the input related operation or memory related operation. So this pin helps the microprocessor to get the difference between input related operation or will it be a input related operation or the memory related? Or will be the memory related operation. So when this pin IO or M, when this pin will get the low value, that means 0 volt, or IO M bar will get the 0 value, so that means it will start to indicate, or it will start to perform the memory related operation. It will start to perform, microprocessor will start to perform, it means microprocessor microprocessor will start to perform memory related operation. Microprocessor will start to perform memory related operation when it will get the high value, or this was 0 volt and it will 5 volt, or you may say 1. Then microprocessor start to perform will start to perform input output operation. So these were the basic function of this pin IOM. Input output when it will get the high value or 5 volt, or it will start memory related operation when it will get the low value or 0 volt. So these were our 4 signal, like first from the first x1, x2, clock, out, read, write, and IOM. So now by combining these 3 signal, read, write, and input output memory, by combining these 3 signal, these 2 and the one is this one, so by combining these 3 signal we can generate more different type of signal. So what are the more different type of signal that we can generate? So let's draw a chart and we will try to understand. So let's first erase those things. Read, write, IO read write operation, control signal. Operation control signal. So these were the 3 signal. So first we want to perform memory operation. That means 0 0, when we will provide the low value, the memory related operation will start. Then 0 1 1 0. So here if you will see, read signal will be activated when it gets low value, and write signal will be deactivated when it gets high value. So memory signal as well as memory operation as well as the read operation, so that means operation will be memory read, and the control signal will be denoted as this one. We will see this thing when we will draw the timing and control. We will draw the timing diagram of different type of instruction. For the second signal is also the memory signal. This second signal would also be the memory signal. This is because it is also getting the low value. It is getting the read signal is getting the high value. That means it will be deactivated. Write signal is getting the low value. That means it will be activated. So that means memory write. Memory write. This is also a active low signal. This is also an active low signal. Next thing 1 1 0 1 1 0. So our third signal, which will be a input output related operation, because it has got the high value or high voltage 1. So and here you will see it is 0, that means it has got the low value. That means it will be read related operation, and it will be deactivated because it has got the highest value. So here is a input output, another is a input output is here, it is a read. So input output read operation will be performed. Input IO read operation will be performed here. Now our last or the fourth operation, which is you can see here, it will be what? It will be, as you can see, 1, and this will be the input output related operation. Read signal will be deactive because it has got the high value, and the write signal, it will be also active because it has got the low value. So input output, it's a write, so operation will be IO write, and which is IO write. Active low, active low, active low, active low. So all four signal are active at low. So by combining these three signal, we can generate the four different type of control signal. Two are the memory related signal and two are the what? Input output related signal. So that we can see over here.